Good morning, Shivani.
Excuse me, ma'am.
हाँ शिवानी बताओ. Yes, Shivani. Are you saying something, Shivani?
Yes, ma'am. Ma'am, I was
Hmm.
asking when will be our like presentation? Is it in this class or the class published at 3?
We'll have at 3, I guess, right?
Okay, ma'am. Thank you,
Mhm.
ma'am.
Okay, so good morning, students. I hope I'm audible.
Good morning, ma'am.
Yes, ma'am.
Yeah, please let me know if because the Wi-Fi is very bad, and if you don't listen me or you don't hear me, just let me know, right? Okay, students. So today we are going to study a very interesting and important topic in a plant tissue culture. Probably we'll have have one or more topic. We are done with the syllabus, right? So we are going to discuss about the secondary. We all know about the secondary metabolites, right? We know the secondary metabolites are compounds which are being produced by the plants, and directly they don't have any kind of a role in the metabolism, but they are being used maybe as a plant defense mechanism, or they have a very important medicinal properties or other properties, like we can utilize those secondary metabolites. So these secondary metabolites can also be produced, or we can do by the plant tissue culture method. So that is the first topic that we are going to discuss. And second topic, a very small one again, is the edible vaccines, right? So the this is not an old concept, right? When we talk about the edible vaccine, there are a number of vaccines which are being developed in this way, and they have definitely many advantages, but still it's a people are still working on it to standardize the thing, because there are certain shortcomings, right? So we are going to discuss what are edible vaccines, and how they are being made, and what advantages and disadvantages they are having. So these two topics are for today. So secondary metabolites, I guess we all have heard this term many times when we were studying plant science or any other things. So these are the chemicals which are produced by plants, for which, yeah, as I told you, there's no role, no actual role has been assigned to them in any growth or a photosynthesis or a reproduction or any other primary plant functions, right? These chemicals are very diverse, and they have been identified in number of classes, right? We'll discuss that also. So each plant family, genus, and species, they produce a characteristics mix of these chemicals, and sometimes they can be also used as a taxonomic characters in the classifying plants, that particular these families, these are producing these kind of chemicals or secondary metabolites, right? And humans use some of these compounds as medicines, a flavoring, or a recreational drugs. So these are being used in many industries with wide applications, right? So they can be, again, if we talk about the classification, they can be classified on the basis of chemical structure, right? For they have a ring, they have a sugar, they some have a nitrogen, some don't have a nitrogen, some or on the basis of their solubility in various solvents, right? Or simple classification is like three main groups: the terpenes, which are made from malonic acid. These composed almost entirely of carbon and hydrogen. Then we have phenolics, which are made from simple sugars, and they contain benzene rings, hydrogen, and oxygen. And then we have nitrogen containing compounds, which are very diverse, and they sometimes they have the sulfur also, right? So since they don't have any mm, important role in any of the primary function in the plant, right? So when we talk about the secondary metabolites, they have they are they are supposed to have a negative impact on other organisms such as herbivores and the pathogens. So they are important, right? So they are, at least they are doing something. Maybe they are not taking any directly any part in the growth and the reproduction of the plant, but then maybe as a plant defense mechanism or certain other mechanism they are being used. So it leads to the hypothesis that they have evolved because of their protective value. So they give certain kind of a protection to the plants against the pathogens, right? So many secondary metabolites, they are toxic or repellent to herbivores and microbes, and they help defend plants which producing them, which plants which produce them, they defend those plants, right? So production increases when a plant is attacked by any herbivores or a pathogen. So this fact, right? This fact, when this is a scientific proven fact that the production in a plant increases when any plant is attacked by herbivores or the pathogen. So this shows that they have a certain kind of a role in repelling pathogens, or maybe managing pathogens, right? Some compounds are released into the air where plants are attacked by insects. These compounds, they attract parasites and predators that kill the herbivores. For example, alkaloids and terpenoids, they come in this kind of a group. Then secondary metabolites can be produced by using different biotechnological approaches, such as we can use a callous culture, we can use a cell suspension culture or organ culture to produce these kind of secondary metabolites. Now, these are the certain examples where the secondary metabolites are being produced in the organ culture. For example, the root cultures, they say, are the valuable sources of the medicinal compounds, and many of the secondary compounds, for example, tropane alkaloids, they were produced quite well in the root culture, right? So, root system of higher plants, however, generally exhibit slower growth than the culture of undifferentiated plant cell, and are sometimes they are difficult because roots, they don't grow that much, the growth is slow there, right? So sometimes they are difficult to harvest. Then these can be produced in the callous cultures also. So we all know the callus, right? We have studied this already, that unorganized mass of the cell, and which can lead to the production of the plant further. So callous culture is the culture of plant cells induced on a media which contain high concentration of auxins, or maybe a combination of auxin and cytokinin in certain ratio. And then this callous culture can be embryogenic and non-embryogenic both, right? So embryogenic calli, they contain differentiated embryogenically competent cells that can regenerate complete plant through somatic embryogenesis. So somatic embryogenesis we have already discussed, right? So the main use of this somatic embryogenesis include, we know that, clonal propagation of a plant. What does clonal mean? Similar plant. Clones of the in starting material that we have taken, right? So we don't want any variations. We are producing similar kind of a plant. Then regeneration of a haploid or a transgenic plants, and fundamental study of the process of embryogenesis in the plant can be done by this, right? And non-embryogenic callous cultures, which contain more or less homogeneous clumps of a de-differentiated cells, they are also used for, just a moment, give me 1 second. Just give me 1 second, huh? I'll join. Just give me. Okay, students, I guess I have to join some important meeting which is going on, and it is important. Sir का भी call आया था, so maybe I'll complete this in the session that we are taking evening. एक ही presentation है ना शाम को, तो इस topic को भी हम वहाँ cover कर लेंगे, ठीक है? So for right now, I'll be leaving for the meeting. I'm really sorry, right? Okay, I'll close the meeting. You hear me, right?
Yes, ma'am, we can hear you.
Okay, I'm really sorry. There's a call from the side, so I have to attend some meeting going on, right? I'll see you in the evening class. Fine, bye.